In this video, I'm going to discuss hydrogen bonds. But before delving into hydrogen bonds, we need to talk a little bit about polar molecules. Polar molecules must contain one or more polar bonds, which result from a difference in electronegativity between bonded atoms. An example would be water, H2O. This is a polar molecule. In H2O, the electrons shared by the oxygen atom and the hydrogen atom spend most of their time near the oxygen atom. This unequal sharing of the electrons causes the oxygen atom to have a partial negative charge and the hydrogen atoms to have a partial positive charge, as you can see in the picture here. A polar molecule may be electrically neutral overall. Again, we'll use the example of water. H2O is electrically neutral because it does not have an excess positive or negative charge. So hydrogen bonds form between polar molecules. Polar molecules arrange themselves such that the partial negative pole of one molecule is close to the partial positive pole of a neighboring molecule. The attraction between the partially negative and partially positive regions of the neighboring molecules is called a hydrogen bond. So let's take a look at this picture here. We can see we have water, H2O. Oxygen, again, is partially negative, has a partial negative charge. The hydrogens have partial positive charges. Therefore, if you look at the central the water molecule here, it's oriented such that hydrogen is pointed upwards towards the oxygen of another water molecule. The oxygen is pointed to the side towards a hydrogen end of another water molecule, and so forth. So basically, these water molecules tend to cling to each other a little bit. And that actually gives water very interesting properties, such as surface tension and so forth. So it gives it very interesting properties. And it's all due to these hydrogen bonds. It also means that water is very good at, as a solvent, meaning lots of things can be dissolved in water very easily. And that's something we'll see in a future video. Now, compared to covalent bonds, hydrogen bonds are very weak. So you might think, well, what are they good for if they're so weak? Well, it turns out hydrogen bonds are very important for biological molecules, such as proteins and DNA. And the reason is proteins are actually have this, they're like little molecular machines within your body, within your cells, and they're not rigid. It can change their shape a bit. And why are they able to do this? Well, because they're able to do this because of these weak hydrogen bonds. So that's actually an important property of a lot of proteins within your body, in your cells, is that they can actually change their shape a bit. Otherwise, they simply wouldn't be able to do their function. And similarly, if we look at DNA, you're probably aware that your genetic material is stored in the nucleus of the cells within your body in this molecule called DNA. Well, DNA is this double helix, has a double helical structure, and running down the middle of this double helix structure are actually hydrogen bonds. Why is that important? Well, DNA is actually able to open up, and this allows for information within the DNA molecule to essentially be copied and used to make proteins. And this is also important for the replication of DNA. So hydrogen bonds are incredibly important for your body, for the health of your cells, and so forth. So we'll be talking a lot about hydrogen bonds throughout this course. Well, that's it for this video, and we'll move on to the next one, and we'll talk a little bit about water in the next video.